almost every space vehicle or every space mission.
You see, the space debris gets into fragments because internally, the gases and other things and the unspent fuel, they evaporate and then they burst. So that creates number of small pieces. Then the second is the satellites which are already, life is over but they are still staying in that place. Normally the batteries will explode, so that will also explode full satellite. So there are now methods of safeguarding this kind of events. In spite of all this, we have got close to about 14,000 plus objects in the most standard orbits like the polar orbit, low Earth orbit, and also on the geostationary orbit. So in this, what is being done is there is an North American radar tracking system US Air Force was operating. So that is the phased array technology. So on the entire hemisphere, all around 360 degrees, whatever objects rises in one horizon and goes in the other, it will go on tracking, including a small needle size. That powerful radar. So that is how they map and then any change in the trajectory. But this is done with a selfish motive, because the Russians are launching their missile. They have to separate out from this rest of these 14,000 pieces. That is why they are doing all that. But that technology is now available. Then now some people are proposing that a scavenging satellite like catching butterfly. You go with a big net and then go on collecting this debris and then close it and put it in the bag and then finally bring it down or burn it through the atmospheric entry. So that is being done also. And in the space shuttle case, there are things which are discarded, like the equipments which are not needed. Those things also may become like satellites. So, but they are lower orbits, so after some years they will come down and then burn in the atmosphere. And the waste from human space flight that is put in a canister, in the re-entry it is getting totally burned. So managing the orbit debris is one big problem now for all the countries. Yeah, okay.
I'll call up the names. Please ask your question. Kriti HS.
Kriti, okay. Technology. This is not really, general theory of relativity or the space-time has not really directly fed to there is only one satellite built to check the validity of the general theory of relativity, clock slowing down and other things. So, Stanford University, there was a very, very high accuracy gyroscope, electrostatically suspended gyroscope was constructed, which was put in orbit, and a standard clock on the Earth and in the orbit, they had the minute difference, it has been checked out. But it is a NASA-sponsored project to validate that they finally wrote, Einstein was right after all, like that, that is the title which they concluded by the NASA experiment. But the thing is, on the other side, when we say the contribution from Konstantin Tsiolkovsky, rocket staging technology. He was a mathematics teacher in a school, remote village in Russia, in the original USSR, and he dreamt of these planetary missions and all that kind of thing. So any conventional rocket cannot attain more than some 4 km per second or 5 km per second velocity. So by discarding the spent stage and then oscillating again the smaller part, you can build up velocity to escape the Earth's gravity. That was his first and foremost contribution, when no rocket was even built and launched. Other than Chinese and some other people in either our Hyderabad team in Srinagar, they built rockets for fighting war, but they are all very short, low velocity missiles. But this is escaping Earth's gravity. First time he did. Then there was Sanger and many others who also thought of going to moon. And Jules Verne, his original thing to lunar mission. Those things are all, you can say science fiction, but it became true eventually.
Sir, one more question.
Yeah.
Transporter technology.
Which one? The
transporter technology.
No, transport means you want space transport. Space transportation. No.
It can be given the velocity of light or something.
No, you see, there is electric propulsion where you can accelerate the electrons or ions by magnetic field and also accelerating through the electric power. You can build up higher and higher velocities. So cesium can be ionized, xenon can be ionized, and there are rockets already built. Even in Indian satellite, geostationary mission has been already tested, and one or two missions in future we will be using also. Because that is compared to the conventional chemical propulsion, about 230 to 300 seconds specific impulse. This will be 3000 seconds, 10 times better. Like that we can easily achieve. But beyond that, at the speed of light today, okay, we don't know, because general theory of relativity or the special theory of relativity both forbid the any object attaining the speed of light. So up to that you can go. There is no issue. Okay. Sharmita. Okay. Sharmita, this is in the present day world, major global issues are global warming, then ozone depletion. So what are the engineering ways of tackling this issue? And what is the role of responsible engineer towards sustainable development? Engineer has to sustain himself first, I think. That is the most important thing. So many things are becoming selfish motive. Because of that, you always highlight this is a better solution, that is a better solution, like that. Because the negative effects of anything is not highlighted when a new patent is taken or a new process is invented. So that is where we have the problem. But this global warming and other, the Arctic ice melting, Antarctic ice melting, and all those things. The thing is, if we have the precision, economic precision, 23,500 years and all, once in that kind of long period, many things happen. So some equatorial becomes warmer, cooler, that is one thing. Ocean currents are changing. So there are many issues. So 1 or 2 degree change in the ambient conditions can cause lot of problems. Increase the emission of carbon dioxide. Initially, the plants absorb them, become more productive. It is not the other way. Many people are actually harassing people, saying that is harmful. Initially the yield will go up, but afterwards it will come down. So that is where we have to really understand the science of photosynthesis very, very clearly. Because photosynthesis cannot be even today simulated in a lab by electronic circuit. We are still struggling. So paddy or the rice cultivation all the photosynthetic processes are not even 1% or 1.5% efficient. Capturing the energy coming from sunlight, not even that 1% of the energy is finally getting to chemical reactions and then to produce useful carbohydrates or other things. In addition to emitting oxygen back, these are water is required for that process. But when we do all this, the global warming, finally the new deserts will be formed and all the green vegetation will die. That kind of thing is eventual. But by keeping your own emission norms, whatever you are doing now, you don't exceed that. That is one thing. But we are a developing country, there are developed countries. Americans take almost 100 times more energy input than Indians. This is the kind of number the Americans are using. And they say we cannot, sacrifice our lifestyle. But you don't have to come up to our lifestyle. So, you just stay where you are. You use oil and all kinds of things, they will say gas-free oil you use for study, all those things. That is the kind of thing which they are preaching. That is one side. Other is scientists and engineers. The Nobel Prize winner, from India, the chairman of the ICC. So he was finally, that report itself had some flaws. We had the problem. So now we have to correct it and then see when it is the old story, the 5 musicians and a cook. The people, they were traveling for performing in some place, but when they were to lunchtime, so they carried all the rice and all that, but they have to get water and some, firewood. So the fellows, that cook only can cook. So all these people didn't even know what will be available where, the musicians. So finally, a lot of struggle, that cook has to find everything and feed them. So the scientists are like the 5 musicians today, I am telling you, because we are not putting everything together. We are narrow focus on one thing but not the global focus. So that is where we have this problem. So the environment and global warming, India has to definitely carefully do something minimal. That is the per capita energy consumption. When it is going up, it should be for something more useful than what we have been doing. So energy efficiency, energy audit, there are many other tools where engineers can help minimizing the need for additional energy. That is the thing. Yeah. Next.
Told that we had to have this, we have been self-reliant. But recently I read that for the power system supply, for power supply systems, for our supplies, we are procuring them from the other countries. And moreover, because of that malfunctioning, in the past 3 years, we have lost as many as 3 satellites. So, still do you say that we are self-reliant in the communication sector?
No. You see, as I said,
we lost, about 2 years back, we lost W2M satellite, and just it's been reported that Insat OB recently reported the same problem. That is the problem in the power supply system.
Yeah, you see, I will tell you the answer. That is, solar power, panels we saw on both sides of the satellite.
Yeah, what's been said is they are importing the solar cells, and then they are making use to construct a solar panel.
Yes.
They are not actually preparing the indigenous solar cells. So, where exactly the problem lies and why it has not been?
I think who are all the physics teacher, I think they should excuse me, because the physics community of this country has let us down very badly. Why I am telling, there is pure silicon crystals, 99.69 purity. You need to make the solar cell. It is just a PN junction. PN junction, you know what it is. So, very simple, PN junction diode. But it is receiving a photon and then, because the solar spectrum, you get number of photons coming. Photon interacting with the crystal structure, it has to release the electron. And that has to be taken through a circuit path. But what has happened is 99.69. It requires ultra pure, gases, ultra pure water, and also non-stop power supply to run the furnaces which are actually purifying these things. Zokalski and many other products are there. So there have been attempts made in this country to make indigenous silicon wafers. It is not yet successfully done. Metal chemicals in Baroda, some group, many others attempted, but it has not come. Also for power, all our electric locomotives, they require power, converting transistors. And that again, were high power, thyristor equivalent. That also 6,000 horsepower engine. You need power devices, which is again not available in this country. Bharat Heavy Electricals is supposed to produce in the Bangalore facility, but not yet done. In our time, in 77, we got some solar cells made in solid state laboratory to Delhi, then Atomic Energy Department Bombay, then Bharat Electronics, and also from BHEL. All the 4 we put some small experimental chips successfully launched. We also got the characteristics, but we got 10%. At that time the state of the art was 18%. So we are 50% efficient at that time. Today the 28% is there. It is not pure this thing. Now gallium arsenide cells have come, gallium indium arsenide has come, gallium indium phosphide has come. These are people and multi-junction cells. So it is a big thing where we have to now really embark on. Solar mission is launched by our honorable minister. Even Karnataka is getting 3 places. Kolar has won already 3 megawatt, but that is a German solar panel on the ground. So we have to go a long way. As I said, many places we have not completed the thing. Crossing the well 90% there's no meaning, isn't it? You have to cross the full well, no? So we are not yet done in many areas. So this is one such vital area. Okay, thank you.
Okay, Nandakishore.
Yeah, Nandakishore, right? Yes.
There were no successful manned missions to moon since then.
Yeah.
What is the reason behind this?
You see, there is always, there is a romantic phase for everything. Then, it becomes something routine and mundane. So, there was not much afterwards to go to moon with men on board. So that is how the missions are not conceived after that. And the major moon missions, Apollo era was over. Then around Earth orbit, the same hardware was put to use for Skylar. Pharmaceutical processing, electrophoresis equipment will perform more than 400 times more efficient for separating especially the protein and other things. Membrane separation. So these kind of things are more of interest to commercial people, not the moon. But the studies are continuing. Now the helium-3 abundance on the moon. Someday when Earth runs out of all the resources, maybe that will be the only source where you can get your power source later on. So you must have your area reserved. So it is not illegal occupation, but with the UN sponsored approach, one who demonstrates technology and means to go there and operate, he will give license. So, but you must demonstrate. So that is how now again the renewed interest on moon has come. So that is the current thing. And now finding a water molecule on moon, it saves some trouble of carrying the water from Earth to moon for the entire operation. So there may be a chance to even make liquid propellant like liquid oxygen and hydrogen on the moon. So then your rocket fuel also can be manufactured there. So these are studies. So Peter O'Neill, the Princeton University professor thing, Space Colony, you might see that book. He is no more, but he is one of the dreamers like Kurzweil on the space colony. So because launching a rocket from moon costs much less energy to other planets than going from Earth. So you have a kind of a base camp at moon. That is the idea. Okay. Yeah, next. The first question, I think, some few days back, we found that our indigenous medical systems, the Siddha medicine and many other things, there are things which are going to nano level. So one thing is the surface area increases because you are going to smaller and smaller sizes. So the effectiveness increases. So some people say even homeopathic medicine might be working on this principle, but it has to be demonstrated. But to make this carbon-based nanomaterials, carbon nanotubes which are cylinder or a flat thing like graphene, these things. Now in the oil lamp, especially the castor oil plant, the food which is going up, that contains primitive forms of the carbon nano elements. So your eye, what you put that eye glass, that and the bindi, these two also eventually will use nano. So there is a big market waiting. Okay, no issue. But the other part is about the electronics and other things. Whether the superconductivity will be possible with the carbon nanotubes, it is not so. But the other things like, high temperature it may operate. That is the other extreme. So these are things which are going to come soon. But here again we are, at the tail end of the race. So some people who are already advanced in Germany or in Japan or US. So the patents will cover a lot of things. So unless we originate something here, we will not have intellectual right for the thing. We have to pay a huge sum for getting the things. In India, only few places this kind of work is going on. But on the corrosion prevention, on steel structures, paints, the titanium dioxide in nano form, and cement and concrete in nano form. There are many other activities of research going on. So I think we will look for something where it is engineering perspective or it is coating the stent. I think because heart surgeons will know, when you are placing the stent, it is to be also immune from the, biocompatible. So coating is given on that. That can be in nano form. So these are already in lakhs and lakhs. So only if you tell it in dollars, it will be $2,000 or $3,000. A little reasonable to hear, but otherwise it is lakhs. So for many people it is unaffordable. In India, if something happens, that would be a good application of the nanotechnology. Okay, thank you.
We intend to give a small break because of the continuous barrage of questions. I now request the Presidential Officer of today's program and the Chairman of the West India's Relations Committee, Dr. K.R. Sridhar, to address again.
Padma Shri M.Vasagam, Shri Devendra, dignitaries in simple terms about space technology. Probably you all must have received one message what Padma Shri M.Vasagam said. When he started the project, he was not knowing what he was not knowing. That is, we don't know what we don't know. That means we must have confidence. This is very, very important. I think you as, of course, viewers, your age already, you as young community, builders of future India, I think this should be remembered. With confidence, you can achieve anything and take India to the 21st century. Secondly, he also gave a caution. In spite of our advancement, one we should know is pollution. Pollution of environment, pollution of mind, without getting a lot of stress, without polluting the environment, we have to go beyond progress. But sir, one secret I still don't know. Probably Madam knows about it, Madam Vasagam. He always keeps on smiling. Just see, Vasagam, since morning, say 1 o'clock, I have been seeing him. Sir, I got a secret, Madam must be knowing. So, I think.
Now is the time to felicitate the honored guest who is with us today. I now request the dignitaries on the stage to felicitate the guest, Shri M.Vasagam.
Beam from satellite in imaging and global security. Right now normal camera takes picture with reflected light. Either sun or you have the plasma. But the radar can do the same. It can put in the microwave or other frequency. So the return signal also can produce images. So that is the model for the radio wave. You can get the whether in day and night. And it need not be sunlight period alone, it can be night also. So we have radar satellites which are also being done as part of the remote sensing program in India. But only thing, the resolution in that will not go to the 1 or 2 meters it may go, but the photographic camera can even give much more, and it can produce stereo wave, which is also being done in the remote sensing. So by putting both together, you can see the radar signal will reflect differently from a vegetation, from an airport runway which is full of concrete, or an urban area like this, or a blacktop road. So the signal return will be changing. So with that and the signature analysis, you can get the mapping done. So this is effectively used in the whole thing. So beyond our borders, if we want to look at the national security angle, there are needs of that kind, including detection of the intrusion of other enemy kind of tanks and other things. So that has to be looked at, and also the small objects which are coming from other side, it can also be picked up. So these are the uses of the imaging kind of thing with microwaves and the electromagnetic waves. The light is also part of the electromagnetic wave only, but here the amplitude and phase both will be reduced. Okay, thank you. See, normally, the water molecule detection on the moon, when the instrument was carrying moon mineralogy mapper. So it was not mainly designed for detecting water molecules, but it was meant for other things, like iron, aluminum and other things, heavy elements. But this water molecule was also detected as part of that signature. So this was an unwanted part of the spectrum which they were looking for. So the instrument is capable of detecting this. So this is like mass spectrometer. How mass spectrometer works, there is a magnetic field, electric field. It is just like an oscilloscope in some other form. So the beams which are once it goes through the instrument, it will get into different, different molecules will go into different channels. So with that you can get the signature of the water. That is the way it has to be done. But the thing is not in abundance. No, it is only forming and then going, evaporating. So because the solar cycle is also there. So on the moon it is not a steady water thing available. Same thing it is so. But on the polar regions of both moon and Mars and even other planets, there is a permanent ice form. Water is in the form of ice. So those things are not ever exposed to sun. So on very low temperature they are actually getting there. So it may be someday useful for the this kind of experiment for really sending man to moon or Mars. That time it will help. That is one thing. Other is the Mars once was like Earth. That theory also will verify. Some organisms which might have survived earlier when water was in abundance, that might be possible to detect the life forms. So some experiments are going for that also.
Okay. Now, any students from the Javalli school can ask questions.
No, this is what, there is water on Mars. Okay, that's over. One more is there, no? From Amrita.
We are not able to devote your time for all those.
Okay, one thing is, we are always in a team. Okay, whether it is ISRO or the university or the educational field, we are always with people. And the thing is, seeing some new places all the time. Okay, that is one good thing in education, because people pass out and the new batch comes along. So that way it is a more advantage. And second is the ability to motivate, because that is one thing which we need. Criticize there are many people, but to motivate you have only few. So that is one thing which you have to see, promote research or any other thing. A healthy competition has to be set up. So that is where I think the education field we are trying to succeed. So this is one thing. But you also know that the R&D lab, the gap between the research laboratory to education. A lot of people say it is education is poor quality, but it is not so. So the entire team which was with me or with Dr. Kalam for SLV or the GSLV, they are all products of the Indian education system. There is nothing wrong with them, and that is one thing which you have to keep in mind. That is, when you are solving a problem, you have to do far more than what you have been taught. So there are two things in the university level of education. One is called lifelong learning, second is learning to learn. These are two things which you have to keep in mind. So when I studied, there was no computer in the curriculum, nor computer science as a field. But we wrote programs for the IBM machines which were at that time available in the country, and the analog computing, and then subsequently we have got now tabletop or laptop, you see wonders. But all this in the last 30-40 years. But at that time when the first active project was taken up in ISRO, it was mechanical calculator. Again you have to go to Visvesvaraya Museum only for seeing that machine. It is number of gears, wheels, and then you hand cranking, you do the arithmetic, addition, subtraction, division and multiplication. You must go and see those machines. But now it has become so fast and so easy on the laptop computer. So this is the kind of things you have to see. But when we say why we have to associate with students and the education institutions, mainly because they are unspoiled mind, number one, and they can ask questions which may even appear to be stupid but not necessarily, and it can be leading to a new product or a new process or a new innovation. So that is what I think we have to keep in mind. Why we have to interact with younger age group people, whether it is in university or college or any other place. So, but I was fortunate to be studying at one institute at Coimbatore, which has produced more than 15,000 people running their own industry in engineering field, and almost contributed to all the pumps and motors which are manufactured in that city, Coimbatore. They are all done by these people, machine tools by these people. School, somebody is there. They are 10th, huh? Yeah, okay.
As you have said that Indians have discovered many things and invented many things, and there are many technologies have come up. Why do you think India is still a developing country but not a developed country?
You see, if you remove that word developing country, all for loan will be stopped. That is one very small but that is not the real thing. But the point is, people, it is like islands of excellence are existing in the country, but it is not put together. That is the point. Islands of excellence. But it doesn't mean anything. You are not, as a nation, you are not producing, you are making, even the school notebook, the small computers, $35 laptop, which was promised by Kapil Subramanian, our MHRD minister. To make it a reality, we need the silicon starting point. What he asked, where are those chips, and then integrated circuits, and the computing operating system. What we are doing is just like enjoying our film show. We are getting the software from somewhere, but we are putting it to use. That is not adequate. So the developing difference mainly. Say Japan was once known for copying many things from outside. It's called already. So why we are not doing it in India? Our own traditional craftsman is making the clay model and then making the Ganesha. But the plastic Ganesha from Beijing has come here, or Shanghai. So that is where we are not exploiting knowledge for economic activity leading to employment, and also employment leading to our conquering outside India market. So that made in India, that what you keep in mind, how many of you can make that as a reality and then outsell in other countries, including China. Then only we can say we have become developed. Then we can start giving loan to others, not going begging God. I will give that one example. When we were 1974, we were doing the first study for the satellite communication. That time France and Germany, we were in Paris, and that 2 months we were to sit with one French company to adopt their system. Then we were staying in the hotel, and then we used to go for the early morning. We used to enter the company's premises. That morning they came and hugged us and congratulated us and all that. We didn't know because we were not seeing the French TV. But we came to know that Pokhran 1 had taken place, 1974. And they said that if India can do that, we will do this also. That is the, respect we got instantly. Then that evening we went to one restaurant in the Paris dinner, evening. That time we got one person from USA, who makes sewing machines in India. That representative had come there, so he was on the table. He said that day he got so much of orders for the sewing machine made in India. If you can detonate that small nuclear device so precisely, definitely you can supply a good sewing machine. See, like that, how they are thinking about us. But at the same time, German Allgemeine Zeitung, that magazine, it is like Hindu of India. The cartoon said, one Indian with a begging bowl, with belly going inside, hungry fellow, and then he is going the begging bowl, and in that there is one, and he has in his hand, one hand he is carrying the atom bomb. So that is German viewpoint of India. Now, I am telling, unless you have respect by doing things, they will not respect you. There is no substitute. There is nobody else can recommend your product to other countries. Question the established authority. That is all the favoritism. This and what another is doing very similar. In those days, there was a big movement in China. And that time, cultural revolution, young people played a key role, and to look at in the new perspective. But in 1 year, they built a heart lung machine. 1 year, heart lung machine was a substitute for operation. It was being imported. And another one, they explored on the dog. And very same thing, they also made oil drilling. 80 million tons of oil was produced in just 2 years in Manchurian fields. In India, we are still struggling from Kedimalaya period to today with 30 million tons of oil only. So these were, as I said, not crossing the well fully is not an achievement. 90% of the well water is in here. So we are crossing many times 90% of the well, 30% of the well like that. So from developing to develop, it is in your hands now. I think whatever you want to do, each one has to think of a way of really going out and finding the goal and achieving it, and finally bring economic prosperity and foreign exchange from other sources of the world, not India alone. Don't drop India, that is the only thing. So, dream. Project. No. Dream means, see, India has got, there is one project of the country, which is at Ahmedabad. It is called Aditya. A fusion reactor, not the fission and other things which we are doing at BRC or Bhavatan Research Center. This is fusion. But we are one of the minor players in that big international team. Separate laboratory at Ahmedabad, exclusively working on plasma research and the fusion research. So some of you, if you are interested in that kind of scientific orientation, you can look for that.
So another question. We have seen submarine which has installed nuclear reactors. Is it safe to have such powerful reactors, and what are the safety measures taken? Are any new technologies involved?
Yeah, you see, you enjoy success. How they manage to tell me. When the person is putting his head into the lion's head or the tiger's head, there is one ringmaster. Nothing should happen to the animal or to the person, performer or the ringmaster. So that is what science and technology is. So So the rules have to be perfectly and continuously applied. Nothing like, I can sacrifice so-and-so's life and all that, some big dams and all when they are built. Sometimes stories come, contractors deliberately put somebody under the mud and then, dam is built. That is not the way science can be built. Okay. So this is exactly the way when nuclear submarine is conceived. There are so many safeguards to be built in, unlike the ground-based nuclear reactor. So this is far more critical than that, and also it is continuous operation, unlike the other places, and there is very limited space under the sea. So there are many precautions that are taken, but it has taken almost 20 years of effort of the research scientists, both Navy and also the atomic energy people together, and then industry. So together they have succeeded in making the first model. So now still we have to go a long way. Because there are, these are all 1960s technology in US and 1960s technology in France. And we are maybe, after completing all this, we may have 2 or 3. That's all we can afford. Now we don't have to have too many enemies, that is another thing. So, for the whole world is an enemy, so the number of nuclear warriors are also more. We don't have to have that kind of numbers. But this is one technology where reliability of very high order is required. See the LCA picture which I showed, light combat aircraft, the pilot's life is at risk. There we have the one failure in 10 million hours. One failure in 10 million hours, mean time between failures. And in the civilian transport aircraft, it has to be one failure in 100 million hours. We have demonstrated, we have tested and proved that it is so. So that is the engineering, the other side of engineering, which is not the romantic part, but the real, most, you can say, the boring part of the engineering. We have to make sure that it works under all conditions and fail conditions. So that is where and nuclear reactor failure also, modeling software and all that. There are many methods. You hypothesize one failure, one pump is not working, then how it will propagate to many other things. So all that we have modeled and then done. There is one world disaster management day celebrated every year. That time, 1 year was the cities at risk. Like that, they will choose a team. All over the world, through internet, they run the competitions, the painting competitions, photographing competitions, essay competitions. So you may look for the website and see whether you can also look for something in the life critical situations, how technology can be applied. That is more. Okay, thank you.
Please,
without mic you speak, I think you are audible. Human to space, no? Okay, you see, one of your mentors, D.N. Suresh, made a very detailed study when you were director of Space Center. We all were party to review that document. So it was 2016 like that, no? That is another 5 years from now. But that looks very ambitious because first of all your carrier market is not qualified for that reliability. That is one thing which is big bottleneck. Second is the training and building the space capsule with that kind of reliability. So that is another major thing which they have to do. Till now we have got like our taxi rights, we got something on the Russian vehicle, then again something on the space vessel. But right now we have to go on our own. Then they all got it first through animal flights to touch it that easily. There is a big protocol requirement. So we hope that most likely the Indian first astronaut team will be from the Air Force. That is clear. And then subsequent missions may be 1 or 2 dummy. There is anthropomorphic dummy. The astronaut will be with the same costume, everything, including the oxygen consumption, whatever. All will be identical to human being. that will be first launched in the loans also will be checked. So then it will be recovered. So we will learn a lot of lessons. So that first milestone is your class to look for the who is going to be the next Indian astronaut. So maybe, I don't know if you are, now how old are you? 80. So you are
all the developments in technology, say about tube devices as of present nanotechnology. But we are neither aware of the past nor about the latest upgradation, and the growth is very rapid. How can we keep ourselves updated about the new aspects?
it is probably more than 20% of those institutions. You will see, So this is not like, Gita Pravachan or something like that, only occasionally heard and then forgot. This has to be, laboratory equipment have to be there. You also have to goal setting, then only it is possible to get this. So one conscious goal is, there is something going on in Calcutta area. The institution of there is one of Padhyapatya. He is one of the oldest technical universities in West Bengal. The Bengal Engineering College is now a university. There they have got a facility for injecting nano rods into silicon. This silicon is not there. That is other critical thing. But if you assume that it is there, adding the nano element, you can take the efficiency to 28%. What I quoted. In India also they are measuring at the laboratory scale by creating nanostructure within the silicon. So it has happened. So this is one extreme thing what I would say an ivory tower experiment is going on. But it has come to common man's compound. Okay, that saves a lot of time. So how much is the gap to close is one issue. The other similar area is in the medicinal, pharmaceutical area. So this is where the nano elements may play much more effective role in curing cancer and many other things they are talking of. But in medicine, apart from the direct effect, there may be side effects. So the side effect, unless it is properly tested, validated, verified, nobody will give approval for using as a medicine. So that is much more difficult than energy sources. And fuel cells, many of you might have heard that word, battery is one. That is anode cathode is there also. But fuel cell is now one of the latest devices which is needed for this country, but now large number. In fuel cell, the electrode elements can be embedding nanotechnology elements. That is because they are titanium, platinum, all kinds of costly materials are involved. So there again the nanomaterial can be made use of. So these are things which you have to see. But as I said, from ordinary things like, putting an outside thin, like, 1/4, maybe one, that is at the most maybe one single atom layer or maybe 2 atom layer on the window pane. So no dust is settling on that. That is also a big contribution for nanotechnology. Satyam Shivam Sundaram equality has done it in its own way. So this is what I think you have to see how their mind works, not the equations work. That is where they are working. Equation is working, no problem. You lose marks if you put the wrong concept. But otherwise the equations are okay. But the thinking process which led them to come to this level, and that is something very, very important. And that is where I think your Arvido's picture should remain. Each and every time when you look at anything, the intense introspection and way of looking at things, it has come by training and also the intense method of teamwork. Not merely because science, nothing can be done individual. So I hope that what is your interest now? Electronics. See, there is something called molecular electronics or small thing. So we have to replace it with number of circuits. So in nano circuits, right now we are having earlier electronic circuits are 90 nanometers. The device size. Now we went to email ID, because that is the simplest. So Vasagam, PASAGIM. So that will do. So you can send it.
Can I enlightening us on the futuristic vision of India in the 21st century, marching ahead confidently to take its rightful place in the community of nations. We come towards the end of the program with my responsibility being to present the vote of thanks. It's an honor and privilege to thank all the people concerned who are responsible for the successful conduct and conclusion of the aforesaid program. First of all, I take the privilege to thank the esteemed guest, the Honorable Sri M.Vasagam, who has graced the occasion, enlightened and delighted, and successfully engineered us a vision encompassing the present and futuristic role of India as a vibrant
भारत भाग्य विधाता पंजाब सिंधु